Hi, I'm Mabelle Allenlou Gonzaga, and I'm going to introduce Ernest Rutherford. Ernest Baron Rutherford of Nelson was born on a farm in New Zealand in August 30, 1871, being the fourth of 12 children. He died on October 19, 1937. Rutherford completed a degree at the University of New Zealand and began teaching unruly schoolboys. He was released from his task by a scholarship at the Cambridge University, where he became J.J. Thomson's first graduate at the Cavendish Laboratory. He also worked with notable people, such as Frederick Soddy, collaborated with Hans Geiger, Niels Bohr, and Henry Moseley. He is also considered as the greatest experimentalist since Michael Faraday. But how do we say so? Rutherford is a central figure in the study of radioactivity, and with his concept of the nuclear atom, he led the exploration of the nuclear physics, hence being called as the father of nuclear chemistry and nuclear physics. He discovered alpha and beta rays set forth radioactive decay and identified alpha particles as helium nuclei. Most important, he postulated the nuclear structure of the atom and discovered protons in the early 90s.
Hi, my name is Clarisse P. Caras, and today I will be talking about the discovery of protons. But before that, let us first define what is proton. Proton is a stable subatomic particle that has a positive charge equal in magnitude to a unit of electron charge and a rest mass of 1.67262 times 10 raised to the power of negative 27 kilograms, which is 1,836 times the mass of an electron. It came from the Greek word protos, which means first. The discovery of the proton is credited to Ernest Rutherford, who proved that the nucleus of the hydrogen atom is present in the nuclei of all the other atoms in the year 1917. How was the proton discovered? Ernest Rutherford observed that his scintillation detectors detected hydrogen nuclei when a beam of alpha particles was shot into the air. After investigating further, he found that these hydrogen nuclei were produced from the nitrogen atoms present in the atmosphere. He then proceeded to fire beams of alpha particles into pure nitrogen gas and observed that a greater number of hydrogen nuclei were produced. He concluded that the hydrogen nuclei originated from the nitrogen atoms, proving that the hydrogen nucleus was part of all the other atoms. This experiment was the first to report a nuclear reaction given this equation, for an alpha particle which contained 2 protons and 2 neutrons, and P is a proton. The hydrogen nucleus was later named proton and recognized as one of the building blocks of the atomic nucleus.
I'm Alfie Lagdameo, and I'll be discussing the gold foil experiment. In this experiment, Rutherford wanted to test the plum pudding model to see if it was accurate as a good representation of the atom. According to Rutherford, he needed a source of alpha particles to achieve it, so he used radioactive elements such as radium, which naturally decays and generates alpha particles. He enclosed it in a container with a tiny space for the particles to appear. Rutherford beams it in a direction of the gold foil, and there's a detector surrounded by a gold foil that has been coated with a fluorescent substance to retain alpha particles inside the detector. After experimenting, he discovered 3 things, and that is most of the alpha particles went straight towards the gold foil. However, some of them bounced back, while the others deflected at a different and large angle. So, he came up to an important conclusion based on it, and then he also realized that the plum pudding model could possibly not be accurate. Now, let's talk about Rutherford's conclusion. Since most of the particles went straight, he came up with the idea that the atom must be empty space. But the fact that most particles bounce back, he also came up with the idea that the atom must have a very dense center, which we know as a nucleus. The last thing we realized was that some of the particles deflected at a different and large angles. And remember that particles consist of 2 protons and 2 neutrons. So, it has a positive Q charge, and we know that the opposite charges will attract each other. So it means that the same charges will repel each other, which is called a force of repulsion. So from the fact that some of the particles were deflected away from the gold foil, thus he came up with the idea that they have the same charges, which is why particles move apart. It must be very dense and have a positive charge, just like the alpha particles. Hence, this conclusion are pretty much accurate for the atom, which is mostly empty space, and there's a nucleus with a positive charge due to the protons in it.
I am Raquel Ibañez, and I will be talking about the nuclear model of the atom. Ernest Rutherford, who described the structure of an atom in 1911, which improved on the plum-in-pudding model. Rutherford atomic model, the planetary model of the atom, or the nuclear model of the atom. The atom is defined by the Rutherford's atomic theory as tiny, dense, positively charged core, called a nucleus, that is surrounded by negative charges called electrons. It describes the atomic model in which all of the atom's mass is concentrated in the nucleus, around which the negative charges, known as electrons, revolve. Atomic model, the positively charged particles, or the majority of the atom's mass, were concentrated in a small volume according to Rutherford's atomic model. He referred to this region of the atoms as the nucleus. Also proposed that electrons move around the nucleus at the speed of light. Also, the atomic structure, according to Rutherford's nuclear model of the atom, which states that the atom contains a large, dense center mass called the nucleus that is surrounded by negatively charged electrons. The current knowledge of the atom is based on this concept. The positively charged protons that composes an element's nucleus are designated by the atomic number Z. An atomic mass contains the same amount of extranuclear electron as there are protons in the nucleus in order to remain electrically neutral.
I am Jemimah Erin Caluya, and I will be talking about the drawbacks of Rutherford's experiment. Rutherford proposed that electrons follow a circular path around the nucleus. This is impossible because the particle will accelerate if it moves in a circular orbit. During acceleration, charged particles radiate and lose energy. This would make the atom very unstable. But we know that atoms are actually stable. Hence, there was a flaw in Rutherford's model of an atom. Rutherford's atomic model was based on experimental observations. It failed to explain certain things. According to Maxwell, accelerated charged particles emit electromagnetic radiation. Hence, an electron revolving around the nucleus should emit electromagnetic radiation. This radiation would carry energy from the motion of the electron, which would come at the cost of shrinking of orbits. So, the Rutherford model was not in accordance to Maxwell's theory and could not explain the stability of an atom. Rutherford model did not say anything about the arrangement of electrons in an atom, which made his theory incomplete.